So good morning, everyone. So let's discuss the test. What do you think about it? Why you cannot get some of the answer?
Forgot, sir. Well,
I will share my screen.
I was doubting myself.
Yes, this is your score. 1.5, 2.5. The highest is 2.5. The lowest is 0.5. Yeah. Those of you who get 1.5 and below, so be careful in the real test next month, right? The midterm exam. Okay, so you need to study harder.
Okay, sir.
Okay, so the question can be very tricky that you need to answer all the possible answer. So I think some of you did not only get 0.5, for example, because you only answer partial answer, right?
Yeah.
So there are in here 50 mean there are two correct answer, but you only answer one. Okay. So this one is very easy. If you have the slide, you read the slide, you already know. But I don't know why your answer is very wrong.
Yeah.
Correct answer there in the marking, right?
Okay. Yeah.
Okay.
Okay.
Which other one? Which for example, this one. Again, you did not study. So classical decision analysis is not decision under uncertainty. In fact, it's the other way around, right? The lexicographic and the satisficing is the one. Elimination by aspect is the one that is the answer. So if you read the slide, I'm sure you can answer all of these questions. It's not so difficult. Okay. Usually, I did not take any material outside of the one that we discussed in the class. Okay, so just read the slides and the material that I give you, then everything will be okay. Anyway, this is first quiz. So based on Fibonacci sequence, the weight is very small. It's just one. Okay, so you don't need to worry. Is there any question about your quiz?
I don't think so because there is review.
Oh, okay, good. So I close this. Okay, so for the game theory, actually, can you see this? I make several code in MATLAB to run all of this computation. Can you see my screen?
Yeah.
Yeah, okay. So actually, you can also calculate by hand, but of course, I want to check my hand computation is the same or not as the computation using computer. So then to verify my computation, I did all this coding. Anyway, so today, I think this is our last discussion about introduction of game theory, correct? So let me give summary about what we discussed last meeting, okay? So game theory is can be taught as part of decision analysis. And we can say this is decision under conflict. Okay, but of course, game theory is very big on its own compared to decision under risk or decision under uncertainty or utility. Okay, and there are several Nobel Prize winners. They are also based on game theory. So this is like very active research in the world. And of course, I cannot cover all the new theory on game theory. In this class is only like the very basic introduction for you. Okay, at least you know what is the terminology. At least you know how to compute like zero-sum games and Nash equilibrium, Pareto optimality. That's all. If you can calculate all of this, so you know the meaning, you know how to use in your real life, that is already fine. Okay, that's my goal. So, in this introduction, I give you a kind of the whole picture of what is game theory, so you can read on your own. Okay, there are two parts, which is cooperative game or competitive games. Both can be with or without conflict. Okay, so, and our discussion in this class is only for competitive game. I will not discuss cooperative game. I have the slide, but if you want, I can discuss a little bit about it. So, the most important competitive game that we should discuss is called prisoner dilemma and also zero-sum game. Okay. There are many names for the games that eventually will make you confused. So I'm trying to organize the thought of game theory. So meaning that I read probably around 50 to 100 books just to read, to make this slide. Okay. Basically, game theory is a strategic game. This is our focus, with these basically competitive games, okay, not cooperative games. Now, the goal is, of course, to organize your knowledge and to increase understanding about outside world. So we have very bold objective in game theory that we want to predict what will be a possible equilibrium in a situation. Okay, so of course there are several assumptions of game theory. One is self-interest. Everyone is having self-interest, no mercy, no compassion. Okay, even if they do cooperative or they do competition, it's all based on self-interest. Second is assumption is rational. All the decisions are rational. Okay, so these are the two main assumptions. And the game theory itself can be summarized into a payoff table. Okay, in this case, you can summarize into, say, if you have two players, in this case, only one table with a row and column. So the first player is called row. Okay, I call usually Miss Row. And the second player is called column. Okay, and for each player, they will have some alternative action that they will do. And then for each action and the action of other player, okay, you will have some certain payoff. Now, this is useful for military strategy. And the assumption here is this payoff is known not only to you as the first player, but also to your opponent as the second player. So practically, you want all players play in the same payoff table. Okay. So using game theory, you will practically think in terms of how selfish people can actually cooperate each other, can also trust each other, and treat each other with loyalty and respect. This is a very important lessons in game theory. Okay, and of course, these are the components. You have a player, you have action, you have payoff, and you have information. Okay, so the number of player can be more than 2. Okay, that in this course we will not discuss more than 2. It's only 1 or 2, and the action means the alternative scenario that we will do for each player, and strategy is a kind of plan of action. So in this case, why we call this strategy rather than just alternative? Because you can make a kind of tree. Where is the tree here? There. So you can make a kind of tree to represent the strategy, tree diagrams. Okay. So, and based on that tree, you can also, this is from the matrix, you can put into tree, but once you make it into tree, you can expand this tree into strategy that eventually you cannot put it back into a matrix. So tree is more general than the matrix, as we have discussed last time also in decision under risk. You remember? Now, 2 games that we will discuss in this course is called zero-sum games and non-zero-sum games. Okay. In zero-sum games, the table is something like this, and this payoff is for miss row, always for miss row. Oh, how about the payoff for miss column? Because the game is zero-sum, then the payoff for Mr. column is just minus of this payoff. So for example, if Miss Row do strategy A, okay, action A, okay, then if at the same time Mr. Column do strategy C, right? So what happened is the payoff for Miss Row is 4, and the payoff for Mr. Column is minus 4. Now, if Miss Row does strategy B and Mr. Column does strategy D, the payoff for Miss Row is minus 5, meaning losing, right? At the same time, Mr. Column will get positive 5. So until here, is it clear or not?
Wait,
Of
Miss Row loses 5, but Mr. Column won 5.
correct. So the winning of Miss Row, meaning the losing of Mr. Column, and vice versa. Okay, so if Miss Row win, Mr. Column will lose at the same amount. Okay, if Miss Row lost 5, for example, Miss Column will win 5 at the same, it is the same amount.
Okay.
So that's why the game is called zero-sum game, because the payoff of one player is just minus of the other player. Okay? If you sum for each cell, they should be 0. Is that clear or not? So,
I see.
okay. Yes, please. You have a question?
So minus 5 for the -5 means
Mr. does action B and Mr. Column does action D, okay? In this,
yeah.
Mr. lose 5 and Mr. Column win 5,
Okay.
okay? So the actual table must be something like this. Can you see? So what is this? Now I have two numbers of payoff. Yeah, each cell of payoff, I have two numbers. The first numbers is for row. The second number is for column. So in this case, you see this is not zero sum.
Both get one. Wait. Let's
Yes.
say
So
$1.
yeah, for example, $1. This is utility,
Yes.
right? So if Mr. Does strategy A and Mr. Column does strategy D, both will win. One payoff. Okay. Only if Mr. does strategy C and Mr. Column does strategy F, then Mr. will lose 1 and F will win 1. Okay, so of course, you can always make the zero-sum games into two numbers, no? You got? So in this example, I can put it this way, -4, okay, this one is -2, this one is -3, and this one is what? +5, right? So the sum in each cell is 0. Is that clear?
Yes, sir. Thank you.
Okay. So I removed the second element because it's already clear, because this is zero-sum game anyway.
Okay.
Okay. So then I just delete that second element. So I hope you understand the meaning of this payoff. Yeah. Why only have one number? That number is representing for Miss Row. Is it always? Yes. That's the agreement in game theory community. Okay. Always row is the first. That means you are Miss Row in this case. Clear, eh? So how to solve a zero-sum game? Okay. Miss Row is always maximizing the minimum row. So for Miss Row, you get the minimum. So 6 and 5, you get 5. 5 and 4, you get 4, right? And then you maximize. You maximize among the minimum. So 5 and 4, what is the maximum? Are you still there?
Yes, Mister.
So, okay, let me repeat.
The 5.
Yes. So in each column, for each column, okay, you get the minimum.
Yes.
Okay. And then from the minimum, right? Here, you get the maximum,
Which is 5.
which is 5. Okay. So that is the story. But for Mr. Column, the way to do is the reverse, right? Because Mr. Column is negative of this. So in that case, what? Mr. Column will minimizing the max. So in this case, for each column, we get the maximum. Okay, so 6 and 5. Now for of the maximum this, now you get the minimum.
Row?
No, it's column.
No. Oh, it's column. Yeah.
For each column, okay, Mr. Column, right? So for Mr. Column, you check the column.
Okay.
For Mr. Column, you check the column. First, you get the maximum. Remember, row is minimizing first, column is maximizing first.
Okay.
Okay, so in this case, 6 and 5 is 6, 5 and 4 is 5, and then Mr. Column will minimizing. So in this case, you get 5. Oh, exactly the same, right? Okay, exactly the same. So when you get exactly the same, then you get what is called equilibrium. Okay, equilibrium mean, okay, this value here, right, is the equilibrium, meaning Ms. Row will select A, Mr. Column will select D. That is the prediction.
Okay.
Payoff matrix, you can predict what will be the movement of Ms. Row and what will be the movement of Mr. Column. Is it clear?
Yep.
Okay. So this is how the game theory works. So this is the simplest thinking that you can find the equilibrium. But the problem is you are not always can find the equilibrium. In here, if you have non-zero sum, okay, you cannot just do similar to zero sum. It is just minimax, maximin, right? So in this case, you will do later on what is called Nash equilibrium. Okay, so these are the things that we will discuss next time. So maybe next week about the thread. After you discuss Nash equilibrium, we can discuss that. So these are some quote, meaning that this is something that you can learn from game theory later on. That once you learn game theory, you will start to learn empathy. At least you can start to think from other people's point of view. You can put yourself in other people's shoes. That is the things that you should learn from game theory. By having selfish ambition and putting your thought about other people, then you will know what strategy you can do to predict their strategy. Okay, so that is the introduction for game theory. Is there any question about this so far? If not, I will go to the next second slide. Second slide is kind of workshop. So modeling game theory. Can you check in Moodle? Okay, so in here, I would like to explain the meaning of game matrix, single game matrix, and then I hope by the end of this lesson, you will be able to develop your own payoff matrix. Okay, that is the hope, expectation of this lesson. Okay, so we just discussed this a while ago, zero-sum games. Okay, the row mean the choices of Miss Row. Okay, the columns mean the choices of Mr. Column. The element, this one is the payoff of Miss Row always, right? And if you want to know what is the payoff of Mr. Column, you just take the negative value of this. Next, if Miss Row select 4 and Mr. Column select C, Miss Row will get 4 and Mr. Column will lose 4, okay, and so on. So these are the explanation of the game matrix. Now, discussion. What is the meaning of this payoff matrix? Anyone?
A tie? A tie. Tie.
Is it tie?
Hmm.
What is the meaning of zero here?
Oh, you don't play? You don't
Zero
play?
payoff, right?
Oh, zero.
Nobody
You don't
gains
start play?
anything from from playing.
No. Be careful. Payoff matrix represent expected value. Okay. So zero here is the expected value, the average value. If you play this a lot of times, okay, each game not necessarily zero. The payment for each game not necessarily zero. Okay. So when you put the payoff matrix zero in here, that means what? The expected value is zero. So it can be plus and minus, but the expected is zero. Clear? Can you distinguish between the expected and the actual value? Okay. Payoff matrix represent expected payoff, not the actual payoff for each game. So expected payoff means you will have a lot of games and then you take the average of those games. These are the payoff. Clear? The meaning of payoff matrix. In reality, you play only one time, but the meaning of payoff is expected payoff. Okay, how about this one? Who win in this case? Any opinion? Who are the participants? Abel, what do you think? Abel, are you still there?
Oh wait, my mom is calling me right now.
Oh. Okay, Nyoto. Nyoto, are you there? Karin,
What is the question?
so what is the meaning of this payoff?
Meaning the average payoff for Mr. Rowe and Mr. Column are the same no matter what their strategy is.
Okay, what's the meaning of 2 in here?
That's the average
What is
payoff
2?
for
Who
Mr.
win
Rowe.
in this case?
Oh wait, so it's Mr. Rowe that wins because Mr. Column likes negatives and
Correct, correct. Okay,
so
you got that. Good.
okay.
Okay, so Mr. Column always lose. So this is unfair game. No matter what strategy he select, Mr. Column always lose. Okay. So this is the game that Mr. Column does not want to play. Oh, how about this? How many players in this case?
Two, right?
I think
Two.
one.
One.
One. Okay. The actual player is
Oh.
only one. The
Oh,
second
yeah.
player is nature. Right? The second player is nature. So this is similar
Oh.
games under uncertainty or games under risk or utility. Right? So meaning that in game theory, you can also, game theory is kind of a generalization, okay? Then decision under uncertainty, under risk, and under utility. Correct? So, now, can you make a game matrix for rock, scissors, paper? Do you know how to play rock, scissors, paper?
Yeah.
Okay.
Rock,
So-
paper, scissors.
Rock, yeah, scissors, paper, like that. Okay. So, who win between rock and scissors?
Rock,
Rock. Between rock and paper.
paper,
Okay. And between scissors and paper.
Caesar.
Caesar.
Okay. So can you make a game matrix? 2 players.
Okay.
You can share your screen. Okay. Who can share your screen first? You can claim your recitation. Hey, your recitation you need to claim, otherwise you will get very low grade in that recitation with this 10% of your final grade. Who want to share?
Still working on it.
Okay.
Can you see my screen?
Okay, sure.
Is it supposed to be like this?
Yeah, rock and rock is
Tie.
tie. So tie you put 0.
Okay.
Okay. And then rock and paper who in?
1.
1 mean rock win.
Yes.
Rock and paper
-1. Sorry.
-1. Okay. Rock and scissor. Rock win.
Sorry.
So plus.
Yes.
Yes. Okay. So paper and scissor. So paper
-1.
lose. Okay. Okay. Good. So again. Where is my slideshow? Yeah. Very good, Lillian.
Okay.
Okay. So this is the game matrix that you just make. Okay. Now, here is another way, another practice. Okay. So I will explain. This is a war game between row nation and column nation. Okay. From here, you will create the game payoff, right? So how to create game payoff from here? So you check the path. So the path for the row is P, right? For the row to go to column nation is P, PAC.
I think you're not sharing your screen.
I'm not sharing my screen. Really?
Wait,
Lillian, you need to close.
okay.
Can you see the war part here? Everyone?
Yeah.
Okay.
Yes, sir.
Okay, good. So you see, this is the map, okay, road map. So for row, suppose it's given that the part for row is PAC. So go to from the row nation to P and then go to A, go to C and then directly to column. Or BACD, so from BACD and then attack column. Or AB directly from A, B, and then column. Okay. AC, ACD, DCAB, DC, and D directly. From the row, go to D and then attack the column. But the path for column is only B, BA, CA, CD, and D. Now the question, what is the size of the game matrix? What is the size of the game matrix? Anyone? How do you know, right? So
I don't know how to measure, sir.
you don't know how to measure. So how many part for row?
1, 2, 3, 4, 5, 6, 7, 8, 9.
9. How many parts for column?
5. 5.
5. That is the size of the K matrix.
So 14.
No,
Oh.
9 by 5.
Oh. The matrix. Okay, 9 by 5. Yeah.
Is that clear?
Yes, sir.
So in this example, okay, you create the game matrix based on the path. Interesting, isn't it? Okay. So the game matrix is not necessarily based on value like money only. Can be from anything, including from the path. Okay. And okay, what is the meaning of -8 in here? And what is the meaning of +3 in this game matrix? Anyone can explain?
So the column win, right? On the C, T, and DJAP.
Yeah. So the if, okay, when the row shows BAC and the column use BA, the column wins 8 and the row lost 8. Okay. Negative here is row will lose 8. And of course, at the same time, the column will win 8. Okay. 3 is the same thing. So when the row use, what is this? DCAB and the column select CD, okay, the row will win 3 and the columns will lose 3. So do you get the meaning of this game matrix and how do you create it from the path? Okay. Now, this is your practice now. I call this game a cat and mouse game. Okay. The cat will enter from the top, the northwest, and the mouse will enter from the bottom there, which is from the southeast. Okay, and there are 4 blocks in the room here to represent the path. You see, now this is the maze, very simple maze. Okay, now they may turn corner, meaning they may meet each other. Okay, but they cannot turn around. In the corner they can turn, but they cannot come back. Okay, both cat and the mouse will travel at the same speed, 1 step at a time. Okay, they are given enough time to cover 1/4 of the maze, which is only 3 consecutive steps. After that, the mouse will be rescued if the cat did not eat the mouse yet. Simple game, right? So the question is, can you make the game matrix of this mouse and cat game?
There's a lot of possibilities.
No. How many possibilities?
Oh, wait.
It's only 3 consecutive steps. After that, the mouse will be removed. Okay, so think about each player with this mouse and cat. Okay, cat will have 8 strategies, exactly 8 strategies, and the mouse also have exactly 8 strategies. These are the all possible strategies. Okay, we call this pure strategies because like the basic strategy.
Oh, they're not combined.
No,
I
they're
thought-
not combined. This sorry, the way I draw here, I draw manually to show all the possibilities. Okay, so you should look at the blue arrow here as one, and the red arrow here as another possible values.
I thought if like the cat only did,
If the
The-
cat do this, the mouse do that. No,
the mouse can do like everything else, and yeah, so like it'll be
These
eight
are
Yeah,
the-
unlimited.
to the power of
Like
two.
they have more than 8 strategies, right, Abel?
Way
No.
more than 8.
no,
Because,
cannot do more than 8. How?
Or
What
so
strategy you can think of that is not in the 8?
I thought if cat did this one, right, the mouse can do this one, it can do this one, it could do this one, and it counts as a different strategy.
Correct. So that one in 8 times 8, which is the
64.
will be
64.
Yeah.
right? The game matrix will be 64. Like this.
Ooh.
Okay. So this is the payoff for cat. Right? 0 means
Yeah.
safe. 1 means the cat will eat the mouse. Right? Of course, in this game, mouse always losing. Now, given that the cat knows the strategy of the mouse and the mouse knows the strategy of the cat, okay, meaning all of this strategy, the game matrix is the same for both cat and mouse, okay, then you predict what will be the movement of cat, what will be the movement of mouse.
I guess cat would go either 4 or 5.
Not necessarily. Probably, okay. So by looking at it, you can think, but there are quantitative way or algorithmic way solving this kind of problem. And be careful, okay, that not always you can find equilibrium. Not always. Not always you can find solution. Okay, now rock, paper, scissors, you already did a while ago, right? See, Lillian did this a while ago. So now my question, can you modify, okay, can you modify rock, paper, scissors, okay, so that the scissor is larger than the paper and the paper is larger than the rock? That means if you win using scissor, you will get 3 points. If you win using rock, you will get 2 points. And if you win using paper, you get only 1 point. And if you lose or draw, you get 0 point. My question, can you create a game matrix for Ms. Row and Mr. Column? The same way of playing rock, scissors, paper, but the value is different. Okay, anyone want to share the screen to answer this? You can claim your recitation point.
I can try.
Okay, you can try.
Wait.
So you copy the value of rock, scissors, paper from the slide,
Okay.
okay, and then you modify the value.
One. Rock, win. Rock, paper. One. Paper. Scissors. Okay, scissors, win.
Mhm. Is this zero-sum game?
Wait. I still look at the. I don't include the minus yet. Wait.
Once you modify, okay, with the rule above, so this is no longer zero-sum game.
Oh.
So you put comma.
Okay.
So if you use paper, if you lose, okay, if you lose, you get 0. Or if you draw, you get 0. Not minus. So the model that you draw here
Oh.
is
Oh wait.
zero
What?
sum. The point is you are in this practice, you practically modify the zero sum game into non-zero sum game.
Okay.
Okay. So, okay. Say rock and paper. Okay.
Yeah, the paper win, right?
Paper.
One
What?
1 point.
Rock and paper who win?
Paper.
Paper win. But
Yeah.
if Mr. say play rock and Mr. Column play paper, so
Okay.
what is the value in that case for Mr.
So the row is -1, right?
No,
Eh.
when you lose, you don't get minus. When you lose, you get 0.
Do you give a
Oh.
slash and give 2 numbers? Or something?
Comma, yeah, you can use comma. Okay.
Oh, like this.
When you win for using seesaw, you get 3 points. When you win using rock, you get 2 points. When you win using paper, you get
You get 1 point.
okay. But if you lose or you draw, okay, you get 0 point. So it is no longer one number. So rock and paper who win?
Rock and paper, so the paper win.
Paper
That's
win.
1 point.
That means 0.1. Correct?
Oh.
Remember, the payoff is always for the row,
Oh, okay.
right? And rock and seesaw who win?
Rock and scissor is rock, right?
Rock win, right?
So that's 2 point.
So if rock, what is the value?
So 2.
2.0. Okay. Paper and rock who win?
The paper.
Paper win. So if paper win, what is the value?
So that's 1.
1. So
see 1.0, right? 1 point, comma 0.
and so on. So paper and seesaw who win?
And there's scissor.
Seesaw. Seesaw, what is the value of seesaw winning?
3.
3. And
and the paper is
Scissor and paper, who win?
scissor and paper. There's the paper. Hey, sorry,
Hey,
scissor.
scissor
Sorry,
win.
sorry, scissor.
So if scissor win, what is the value?
It get 3.
Okay, 3.0, comma 0. Okay. So scissor and rock, who win?
2. The rock, right?
Huh? Rock
The
win.
rock. Yeah.
Oh,
So that's
0, comma.
0 point. Okay.
Okay, and then in the middle, in the diagonal of the matrix is all throw it.
Yeah.
What?
Oh,
0, 0, comma
yeah, I'll draw. 0, 0, right?
0. Yes. Okay, the same thing. Very good. Okay, so you know it. Very good, Michael.
Okay, thank you.
Thank you. Yeah,
Wow.
excellent. Wow, now you know how to make a K matrix, huh? Right? So your answer is similar to this, but maybe the order is different, right? Right?
Oh, okay.
Okay, the order only different, but the value is the same. Okay, next. So who can solve this K matrix? You will create a K matrix of this problem. Okay, Frank cannot remember that if today is his wife's birthday or not, and he goes home late. Everything is closed except for the florist. Now, this is the payoff. If it is not her birthday and he bring no gift, it is okay. So the payoff is 0. If it is not her birthday and he bring gift, she may get confused but happy. So the payoff is +1. If it is her birthday and he bring no gift, she may get upset, -10. If it is her birthday and he bring only flower, she may be happier, so +1.5. Okay, can you make a K matrix of the situation above? So who want to share the screen? Who claim your recitation point?
I'll try it, sir.
Okay, Eugene.
Okay, let me share my screen first.
Yes. So when you claim, you said, I solve the practice of birthday problem. Like that.
Okay,
Okay.
okay, so share.
Share, please.
Okay, so can you see my screen now?
Yes. Everyone can see?
Yep.
Okay,
Good.
so I will make the row here as bring flower.
Right. This is
And
one
this
person
one.
game. So it is Frank's against nature.
Yeah, not bring. And this one is birthday. This one will be
Not birthday. Okay.
okay. So it is said that if you bring flower
Mhm.
and it is her birthday, you will get plus 1.5.
Correct.
If you bring flower, but it is not her birthday, then you will only get 1.
Correct.
But if it's her birthday and you don't bring anything, she will get really upset. You'll get -10.
Correct.
And when you're not bringing anything, but it's not her birthday, so you're safe.
0. Right.
Okay.
Good.
Okay.
The number is
Yeah, I don't know. Maybe I will just use. Okay.
okay. Anyway. So yes. So correct. Very good. Okay.
Thank you, sir.
Thank you. So you know how to create K matrix, right? From a certain situation. So in any decision, okay, if you want to do a decision analysis, the first thing you do is to create the game matrix. And the game matrix represents utility. So you order matter, not the actual value. Okay, the order of this value matter because this represents utility. Okay. So I will share my screen again. So this is exactly what you just answered a while ago, right? Okay, so as the summary of this lesson, so game matrix was developed. How to develop the game matrix? You should consider all possible pure strategies. Yeah. But, okay. So, any question on how to create game matrix?
Not yet, sir.
Not yet. Okay, now it's 10:40. Do you want to break 5 minutes?
Okay, Eric. Yeah, fine.
So
Yeah.
your case is 9:40, correct?
Yeah,
Yes,
9:40. Yeah.
9:40.
Yeah, in here is 10:40. Okay, so 5 minutes. Let's come back 9:45.
Okay.
Okay.
Okay. And we continue with the solution of the zero-sum game. Okay. So I will stop the recording. Okay. Everyone back? Okay, let's continue with our next topic, which is the solution, okay, of zero-sum game. So in this slide, which you can download from Moodle in Revoledo, okay. So we discuss about the computation, okay. I hope within 2 hours we can solve all of this. If not, we can continue next meeting, okay. So in this course, you will learn about saddle point, value of the game, how to do domination strategy, how to do a mixed strategy and linear programming, and certain scaling, okay. The scaling of the mixed strategy scaling. Scaling property. Next. So I repeat this again. You remember we have a single game matrix for zero-sum games where the row is representing the choices of Miss Row and the columns represent the choices of Mr. Column and the element is the payoff of Miss Row. It is equivalent to minus payoff of Mr. Column. Okay, you know this already. So now, if you have this game, okay, can you predict, okay, how Miss Row will select her strategy and how Mr. Column will select his strategy? Okay, based on rational choice that both players are playing safe. So the Miss Row strategy will find the minimum in its row, which is the worst payoff among each choice. then Miss Row will find the maximum among the minima, which is the best among the worst. So in this case, the Miss Row strategy is called maximin gain. Okay, so in formula, you can see this. First, you get the minimum. The payoff is GJK. Okay, look at the subscript JK there. We only minimize for the K, meaning for the columns. And then after you minimize all, you take the argument of the maximum with the subscript J, meaning among the row. Okay, the J star there is the strategy of Miss Row. The same thing, okay, for Mr. Column later. For example, in here, Miss Row will do maximin gain. So for each row, 6 and 5, what is the minimum? 5. 5 and 4, what is the minimum? 4. And then, okay, Miss Row will select strategy A because between 5 and 4, okay, she will maximize it. So we get 5 as the value for Miss Row. So that's why we put star here. Okay. Next, for the column strategy, okay, Mr. Column will find the maximum first in each column. Why? Because this is the worst payoff for each choice. Right? Then he will find the minimum among this maximum. Why? Because this is the best among the worst. So we say that Mr. Column does maximax cost. Okay, so the payoff matrix is now become a cost, which is JK again, the subscript here. So first we'll maximize maximum among the row, and then you get the minimum among this maxima, okay, and get the argument of that, which is K star. So in this case, you see, Mr. Column will minimax the cost. Okay, so see in column C, 6 and 5, the maximum is 6. 5 and 4 in column D, the maximum is 5. After you get the maxima, which is 6 and 5, you minimize. So the minimum among 6 and 5, of course, 5. Right? So Mr. Column will select strategy D so that he will be guaranteed to never receive losses greater than 5. Okay, of course, he hopes to receive loss smaller than, in this case, minus 5. Yeah? Okay, so if you look at this, maximin, the value of maximin is exactly equal to the value of minimax. So in that case, you found what is called saddle point. Okay, when the larger row minima is equal to the smaller column maxima, okay, that is called saddle point. So if the players are rational, they will stick to this strategy, okay, that intersect at the saddle point. So this saddle point is called the game solution or the equilibrium. So can you get the meaning of saddle point? The saddle point is equal to equilibrium. Okay. And the value of the saddle point is called the value of the game. Okay. So unless the opponent, your opponent, is playing poorly, meaning irrationally, so on average, you cannot win more than the value of the game. Okay. If the value of the game is positive, meaning the amount that the rows have to pay the column in order to make the fair game. If the value of the game is negative, row always pays to the column. If the value of the game is 0, this is called fair game. Okay, from the value of the game, you can see if the game is fair or not. Okay, test to you. What is the value of the game? Anyone? Anyone can explain what is the value of the game? Are you still there?
Yes, sir. Value of the game is.
What do you get? What did you get?
I think it's more like who will win, who will get the most. That's the
No.
value of.
No.
Isn't it to see how fair the game is? Wait.
If it is 0.
To
What is the meaning of the value of the game? Karin, probably? Or Stephen? Or Lillian?
so it's a like what is it called? A prediction, how much you're going to win, or which to help you
The
decide.
of the game you get from the maximin equal to the minimax. The value of the game is the saddle point. Okay, I'll give you an example. Okay. So in here, in this game, a while ago, the maximin gain is 5, right?
Yes.
Column will minimax the cost and the value is also 5. So when the maximin gain is equal to the minimax cost, exactly 5 and 5, right? Exactly the same. That means you
Yes.
the saddle point there. Something in red there. Okay?
Okay.
In Miss Row will select strategy A. Mr. Column will select strategy 5. Okay? The value of that cell of saddle point, okay, is the game value, is the value of the game, which is 5.
Which means it favors Miss Row.
Yeah, in this case, me for Miss Row, anywhere, because all the value in here is positive, you see. Right? The value here is all positive, but even among Mr. Column in this game is always lose because it's always negative, right?
Yes.
Okay, but of course, Mr. Column, even if always lose, he want to minimize his cost, right?
Yes.
Correct. So
Correct.
he does not want to lose so much. He does not want to lose -6, you know. If possible, he want to lose -4, right? But if he do that, he may also get -5. So then he will select strategy D. Okay. You see, later on you can see that Mr. Column is column C is actually dominating column D. Okay, later we will discuss about domination. Okay, so here is the step to find the saddle point. So examine the game matrix from your point of view. Your point of view is always the row. And then you also examine the game matrix from your opponent point of view, which is the column. Now, list the minimum in each row and mark it with star, the greatest among these. Okay, and then you list the maximum in each column and mark with the star the least among these. Now, if the two marks intersect in one cell, okay, then the game has a saddle point. Oh, if they intersect in one cell have and the same value, okay, so I need to add here. In one cell and has the same value, okay, then the game has saddle point and the player should use the strategy which correspond to the marked row and column. Now, not necessarily saddle point exists, you know. So if the saddle point exists, then the value of that cell is the saddle point. It's called the value of the game. Until here, is it clear the step of computation or not? Okay, so can you find the saddle point of this game? Practice anyone. Anyone want to share their screen to solve this? And the others will practice also. Come on. Who did not get recitation today?
I haven't.
Okay, then you share your screen and solve that problem.
Wait. Can I use the? So I use the Excel.
You can use Excel, you can use Word, you can use Notepad, you can use any drawing for it. You can also have the screen here that you can draw manually. As your whiteboard.
Which slide is this, sir? Again, I haven't opened the PPT on the.
Oh my goodness. The solution for the zero-sum game.
Okay, now this one. So
can you find the solution? Can you find the saddle point of the game? The game matrix is 4, 2, 3 minus 5.
4,
4, 2, 3
2,
minus 5.
3 minus 5. So I take the
For the row to get what?
maximin, right?
Yes, maximin.
So it's 4 and 3.
First you take the what? The minimum, right?
Oh,
Maximin mean you min first and then you max.
oops. So
2 and minus 5.
why I cannot? Okay,
Because you are still
2
in
and
operation. Minus
minus
5.
5.
Okay. And then for the column,
For the column,
you do minimax. So you max first and then you get the min. Max among the column is 4 and 2.
May I guess the answer?
Yes.
Is it 2?
Yes.
Okay.
Okay. Very
it's
good.
this one and this one, right?
Right. Because now from that, okay, from among the row, you get the maximum, and then among the columns, you get the minimum, right?
Minimum.
Okay,
Yes, sir.
so then where is the game value?
The game value is 2.
Correct. And what is the strategy for row?
For row,
What is the
is
strategy for row? Okay.
oh,
Yeah, of course,
Uh,
the first row, right?
D, yeah, yeah.
A.
The
Okay.
A, yeah, A
Okay.
row.
And what is the strategy for column?
I think D because like
Correct.
get -5 and then
D, because now the game value is 2, right?
yeah.
Okay. So you can see that you can predict the movement, okay, of each player now based on the K matrix. Is that clear?
Yes, sir.
Okay. So next practice. Okay. Can you find the saddle point of this cane? The oil drilling cane.
Okay. Yes, sir.
So
Let me.
who want to share?
Oh,
Who did not get the recitation point yet today?
Me.
Okay. Can you find the saddle point of this game with this -7, 10, 1, -5?
I don't think so.
Why? You did not calculate yet. Okay, show me
Yeah.
station. Okay. You can share your screen and show me your computation to back up your argument. Yes, in the slide I show you, but I did not show the computation, right? So you need to show the computation so that others will also learn from this. Come on. Who want to share the screen? Who did not get recitation point yet today? Or who want to get double recitation point today? Or triple?
I need to find the settle point again, right?
You need to find the center point.
Wait. Okay.
The same technique, huh?
I think so.
Okay, share your screen.
Share the whiteboard again, right? Okay.
Are you going to do it, Nyoto?
Yes, I would like.
Okay, so share your screen now.
I share the whiteboard again, yes, sir.
Yeah, fine.
Okay, clear.
So you delete all, but you can start to. So the game is -7, 10, 1, -5.
-7.
-7, 10, 1, -5.
And
Oh, 10
One.
is that one.
oh, this one is 10.
Yes. And the
This
other one
one.
is 1
This one is
-5.
1
And
-5.
then -5. Okay.
So
You put double line so that you will know that this is not the no after.
which one, sir?
Distinguish the game payoff and the computation. Can you? And what you will do? Yeah, there.
Here, I find the minimum again.
Yes. What is the minimum? -7 and -5. And get the maximum from that. What is the maximum from that?
1 and
5. What is the -7 and -5? What is the maximum?
-5.
Correct. Can you put star in the -5? Okay, good. Now go to Mr. Column. You will take maximum, which is 10 and 1. Okay, and what is the minimum? There, correct. So you see the minimax is not the same as maximin.
Yes. How
Right.
and then how to make it same, to make it a saddle point?
Okay, very good question. So later we will calculate that saddle point through mixed strategy. But at this point, you see that there is no saddle point.
Yes, sir.
Okay, so there is no saddle point here. Okay, you keep in mind if the game value, if the maximum is not equal to the maximum is not equal to minimax, okay, then there is no saddle point.
Okay.
Strategy. Okay, for the pure strategy, no saddle point. But for the mixed strategy, you may find the saddle point. What is mixed strategy? You will assign probability.
Oh, okay.
Okay. You will assign weight or probability. Okay. Okay. So the simple saddle point you don't have. Right? Okay. Let's find, this is another technique now. Okay, so you have very big matrix, game matrix, like the mouse and cat game a while ago, right? 8 by 8, right? So sometimes your real game can be very big matrix, not just 8 by 8, probably 800 by 800, right? Because that represents the path. So you may use computer to compute, but at the same time, what is the algorithm or the technique for the computer to do? Okay. One way to do is called dominant strategy. What is dominant strategy? A dominant strategy is a strategy that gives you a higher payoff than all of your other opponent's strategy, regardless what your opponent does. So, say if one strategy is superior to another in all sets, either in a row, yes, please.
I'm sorry,
Are
sir.
you
I
sharing
think
your
you
screen?
haven't shared your screen.
I haven't shared my screen.
Uh,
Anyway, you can also check in the slide.
Yes.
Can you see it?
Yes, now we can see it.
Okay. So if one strategy is superior to another strategy in all cells, either in a row or in a column, then that superior strategy is called dominant. Okay. So row maximizes the value or with its larger row value, and the column will minimizes the value, meaning the smaller column values. Remember, if row, you will find the larger value for all cells. If column, you will find the minimum value, the smaller column value of all cells in one column, in two columns. Okay. Now, not always exists, but if domination exists, then the game matrix is reduced to show later on only dominant row and column. Let's take example. Look at the screen here. So I'll put color here. So look at Mr. This is the payoff of Miss Row, right? Okay. So let's say you want to check between A and B. Okay. So A and B. So look at this. 4 is larger than 3. 2 is larger than -5, correct? So meaning row A is always larger than row B in all cells. Okay, the keyword is all cells. That means row A, okay, is dominant over row B. The dominant win, okay, non-dominant row lost. So you can delete row B. Is it clear?
Okay.
Okay. Now you have this payoff. Okay, this one on the right, right? Next step is, of course, now look at this. In each column now, remember, in the column, you want to minimize to find the smaller value. So look at this, column C compared to column D. Okay, so 4 is larger than 2, right? 3 is larger than -5. Okay, so this is -5. So meaning column D is always equal or smaller than column C. Okay. In column, smaller win. In row, larger win. So in this case, we say column D is superior or dominant to column C. In that case, you will delete what? Which column you will delete? C or D? Hello?
D.
No, dominant. Which one is dominant in here?
C, right?
The
No.
C is dominant.
No, D.
D is dominant.
Wait, didn't
What?
Eugene say D? I thought Eugene said D.
Eh?
I thought Eugene said D.
D
Eugene
is
said,
dominant.
yeah. He said D early on.
Yeah,
And then-
D is dominant. So in that case, you delete column C.
Okay.
Okay. So this column you delete, so you get D as dominant. So, of course, now you can see, okay, finally you can have a reduce, which is the game value. You get the saddle point. Okay, through domination, you can produce saddle point. Can you get the way to do? Remember, row you maximize, so meaning you find the larger of all cells in 2 rows. In column, you find the smaller among all cells in 2 columns. If they exist, then you delete the non-dominant. Okay, the dominant win. Okay. So up to here, is there any question? So here is the real strategy during World War II. In 1943, General Imamura has been ordered to transport Japanese troops across Bismarck Sea to New Guinea, which is West Papua. Okay, this is the real historical event. And General Kenny from the US want to bomb the troop transport. So Imamura must choose between the shorter route of the northern or the longer southern route to New Guinea, when the Kenny must decide where to send his plane to look for the Japanese. This is very big area, you know, and their plane at that time is not as good as today. Okay. Now, if Kenny sent his plane to the wrong route, he can recall them, but the number of days of bombing is reduced. Okay. And this is the payoff matrix of the Battle of Bismarck Sea. Okay. This is the payoff for Kenny. Okay. So Miss Row in here is General Kenny. Okay. Mr. Column in here is General Imamura. So the first number here represents the payoff for Kenny, and the second number in each cell there represent the payoff for Imamura. Now the question is, first, is this zero-sum game? Yes or no?
Yes.
Why?
Hmm. I don't know.
Okay. Why you said yes and you don't know? Look at the sum of
I
the,
just want to say yes.
no, not do like that, please. Okay. Look at the payoff in each cell, and then you sum. 2 plus minus 2 is 0.
0.
1 plus minus 1 is 0. 3
0.
plus 3 is 0. Sum game.
Yeah.
Okay. Now, can you find the solution of this game?
No.
Why? You just learn
Because
to minimax and maximin.
because there is no dominant, right?
Are you sure?
I think so.
Are you sure? Okay. Can you, okay, Darin, can you solve this? Come on. You make, I will stop sharing here. You share your whiteboard. Okay. And then you make the game matrix because this is zero sum game. So it's a single matrix game.
Okay.
So what is the value?
Then
The value is for Kenny. So
2
2,
minus
2, 1, 3. Okay. The value is 2, 2, 1, 3. No,
this
no,
one,
no.
right?
Because this is a zero sum game, so you can simplify it into single
Oh,
games. Okay.
wait.
To Nyoto a while ago. So 2, 2, 1,
1, 3.
3. Yes. Okay. So now, can you find the dominant?
2 and 3,
2,
right?
2 is equal, right? For the row.
Yeah.
Sorry, for the row. Row is A and B. Can you put A and B there so that you will know? And for the column, you put C and D. So you can refer it. Okay. Now, 2 compared to 1, row A is 2 compared to 1 and 2 compared to 3. Is it dominant? Which one is dominant? No dominant, right?
Mm.
Okay. How about column? 2 compared to 2 is equal. 1 compared to 3 is lower.
3.
1 is lower. So which strategy is dominant? Between C and D,
D.
which strategy is dominant?
D, right?
No, in column, you find the smaller. In row, you find the larger.
Oh, so C.
Correct. So you can remove column D.
Hmm.
Okay. Only game matrix of like that. What will be your strategy?
Minimize it.
Hmm?
Minimax. Yeah.
No, now you have no need minimax. So you can do domination. Now you have 2 rows, right?
Yeah.
Okay, now you have 2 rows with the column is only 1, right?
Mm.
Okay. Between the 2 rows, which one is dominant?
A.
A. So you remove B, you delete row B. Ah, very good. Now you get game value with this
A. 2.
AC, which is 2. Correct.
Hmm.
You get the solution.
Okay.
So you got it?
Yeah.
Okay. Easy, right?
Yeah.
Okay. At first you see, oh, Kenny had no domination, right? After that you see, actually, Imamura, okay, the north dominate the south. So, and then you delete the south, right? After that, you can delete the, between the row, now you can delete the non-dominant, which is the south. So eventually you see, you get the strategy north-north, okay, for Kenny and Imamura. And do you know, if you check in the history book, that is actually happened. Meaning during the World War II, they are actually already playing the zero-sum game of this game. Amazing, right?
Yeah.
Okay. How about this? This is the cat and mouse game a while ago. Okay. Can you find dominant rows and column, and then you can reduce the game matrix?
I think so.
Okay, you try. Who want to solve this? Use Excel in this case, not the whiteboard, because it's too many. Who want to share the screen? So the goal is not to solve, okay, because it's so big. The goal is to reduce the game matrix from 8 to 8, from 8 to smaller using domination strategy.
I guess 8 and 1, 8 and 1 are gone.
So you need to remove which rows and which column.
8 and 1. 8 and 1.
8 and 1. Okay. So the cats, 5 dominate 1, 2, 3, 6, and 7.
That's strategy 5. Wait.
Yes. Strategy 5. Look at strategy 5.
Yeah.
Actually dominate 1, 2, 3, 6, and 7. That means 5 persist, while 1, 2, 3, 6, 7 you can delete. And the cut strategy 4 dominate 8. That means strategy 4 persists, but 8 you delete. Something like this.
So at the end, it becomes 4 and 5, right?
Correct. And then now for the mouse. Okay. For the mouse, strategy 1 dominates strategy 5. Can you see it or not?
Yeah, yeah.
Okay, because this is always smaller, right? Remember, column is to find the smaller. Okay, row is to find the larger.
Biggest.
Okay.
Okay, so strategy 8
Oh,
for the
1.8,
mouse
yeah.
dominates strategy 4. Okay, but strategy 2, 3, 6, and 7 are alike. That means
Yes, they have.
those 2 columns.
So just 1 and 8 left, right?
Okay.
Wait, why 1
Why
to
is
8?
2 there? Why is 2 still there, though?
2, 3, 6, and 7 are the same. Right?
Yes.
They're the same.
So
Oh,
we're not looking. We why don't we just take 1 and 8?
1 and 8. No, but 2, 3, 6, and 7 are exactly equal, isn't it?
Yes.
So you can select one of them, right?
So you must take one.
Could
Oh,
we go to the next slide? I want again.
this one?
So oh wait. So I guess wait. Why is 2 there? I'm confused why 2 is there. Because
No domination for 2, 3, 6, and 7.
but last with the cat we only had 4 and 5.
Correct, because they are dominant. So in the card a while ago, you see that
Oh, there are no alike. Yeah, there are no same,
no equal, yeah.
no equal value.
Correct.
What?
So wait.
What?
But
I don't
but
get it at all.
all of
Wait.
but all of those equals values are getting dominated by 1 and 8, aren't they?
Yes.
Yeah.
Isn't
Why would
one
you still put it there?
Wait, 2, 3, 6,
So
7.
this is for the row.
for the row?
Five
Shouldn't this include 2 as well then? Because 2, 3, 5, 2, 3, 6, 7 is the same.
2,
2, 3, 6, 7 is the same, right?
Yeah, it's the same with the column.
So what?
okay.
So why does
the-
this not include 2?
because 5 dominate all of them.
Huh?
Yes, 2, 3, and what? 2, 3, and
6 and 7, it's the
7 are
same.
the same, right?
Yes.
Oh, because 5 is flat out better than the other 2,
Correct.
3.
But 5 dominate all of them. So if they have no domination, right? 2, 3, 6, 7, you can select one. Correct?
So 5 has the same but adds 8 as well. It also dominates 8 compared to 2, 3, 6, 7, right?
Yes, but 4 dominates 8. No, 5 does not dominate 8.
I mean, strategy 5 beats Mouse's 8, and it has everything that 2, 3, 6, 7 has.
Correct.
So that's why you get rid of 2, 3, 6, 7.
Correct.
Okay,
Okay.
I see.
They're all alike, but 5 dominate all of them. That is all alike.
5 is simply better than all of them.
Correct. That's why we remove them. But in
So,
a row, we cannot remove them. Because nothing better than this 2, 3, 6, and 7, right?
wait. 2, 3, 6, 7.
I mean, there is no domination. So,
In this one, we are looking for the least amount of ones, right?
correct.
I see. Okay.
So then you can get that, right? So then if you combine the two of them, you get only this. Okay. From here, can you find domination again? Is
So for
I think same.
same, it's the same. 1, 1, 0, 0, 1, 1. It's the same.
the
For
same?
the cat, it's the same.
Yeah, for the cat. For the mouse,
mouse, you 1 and 8.
1 and 1 is the same, so that is okay. 0 and 1 dominant,
Yes.
correct? That means column 1 dominant column 2. Is that correct?
Yeah.
So column 2 can be deleted, Okay, sorry. I think we can copy this. In this case, you can delete column 2, right? How to delete? delete this column there. Correct?
Yes.
So from this table, how do you compute again? Is there any domination? No.
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 No. Okay, so then from here you can you find a saddle point?
I
No.
think so.
I think no.
No.
So say from here the value is what do you get? 1001. How do you get the saddle point? You have okay, let me check here. So you have 1001, right? This is your game matrix, correct? And then let's put the difference. So you want to get the minimum is 0, the minimum is 0, the maximum is 1 and 1. So there is no saddle point.
Yeah.
Yeah. But you can calculate the mixed strategy later on. Okay. Okay. From here, let's this one. Next. Yeah, there is no saddle point. Okay. Okay, let's discuss what is called mixed strategy now. I keep talking about mixed strategy, but I did not define, right? So earlier, the strategy is called pure strategy. What is that? Which is a strategy that you stick to play in a game. Okay. Now, what happens if you play the same game many times, not just one game? Okay. Then what you need is called grand strategy. It's called mixed strategy. Which element for one game, for each game is a pure strategy game. Okay. Now, grand strategy govern your choice of pure strategy to play at a game. Okay, grand strategy or mixed strategy, okay, is the game that let the decision of each particular play is governed by suitable chance device. Okay, so sometimes you use one pure strategy, some other times you use another pure strategy based on certain random probability distribution of each pure strategy. Now, its pure strategy will have some R or certain probability to be played. Okay, so using algebra, remember this drilling oil problem? Okay, so using algebra, we can find that odd. Okay, so say the odd is for the player, the U1 player is X and 1 minus X. Okay, for the nature is Y and 1 minus Y because the probability, right? This so the sum must be 1. Then you can calculate, okay? You can calculate the X, you can calculate the Y.
Your screen isn't showing, I think.
Oh, sorry, really? Where am I? Can you see it now?
Yeah.
Okay, so this is the game of drilling oil. You remember?
Yeah.
The one that I cannot find the saddle point.
Okay, the one that you cannot find the saddle point. Now we can find the saddle point using mixed strategy. Okay? Can you understand the meaning of mixed strategy or not? Mixed in the pure strategy, okay, that means you play only one time. In the mixed strategy, you play the game many, many times. Okay. Now you have a certain probability that you will use this strategy how many frequency, yeah? Frequency of using strategy 1 or strategy 2 or strategy 3 in this case. How many times you will play strategy 1, pure strategy 1, how many times you will play pure strategy 2, and so on. So that probability distribution is the one that you want to find out. Okay, the R. So in this case, you said, okay, the human player, I will put the R is X and 1 minus X, or the probability is 1 and 1 minus X. The R for nature is Y and 1 minus Y, okay, the R or the probability. So you see here, we can calculate using algebra, okay? Minus 7 times X times probability plus 1 minus X times 1, meaning no oil, okay, is equal to 10 times X minus 5 times 1 minus X. Can you see? Can you see this equation here? From where this
Yes,
comes?
sir.
Okay, can you see that this one comes from the payoff matrix, which is minus 7 times X, right? And then 1 times 1 minus X for the left hand side, it is represent no oil. Okay, for the right hand side, meaning you have oil, right? So then when you calculate using algebra, you get X equals 6/23. The same thing in here for the Y, you can get the Y equal to 15/23. Okay, now given the X and Y, right? Then you say, okay, I know the R. Okay, if you multiply the probabilities above with 23, you get the R, with the 6, 17, 15, and 8. That is the weight. Okay, weight of drilling, weight of selling, weight of no oil, and weight of having oil. So having the R or having the probability, now you can compute the long-term expected value for each row and each column, right? So say for drilling, okay, you calculate 15 times minus 7 plus 8 times 10 divided by 23. Can you see? For selling, 15 times 1 plus 8 times minus 5, again divided by 23, which is 15 plus 8. So for each of these, you calculate, okay, and you can see all will produce exactly the same value, which is minus 25/23. So the game value is negative, okay, negative 1.08. What is the meaning? The meaning is the game is actually unfair for the row, for the oil company, okay? Meaning they are losing no matter what strategy to select. So meaning on average, the company cannot win more than the value of the game. Is it clear? You see,
Yeah.
now you can find the game value, which is minus 25/23. Okay. Yes, this game has no pure saddle point, right? But it has mixed strategy saddle point. If you know the probability, then you know what is the saddle point. Is it clear or not?
So that's the saddle point.
Oh, look at the value here. The saddle point is minus 25 over 23, right? The game value. And because the game value is negative, you know they are always losing in this game, right?
Yes.
Okay. And which one you will select? Thrill or sell? Look at the art.
I think so.
Yeah. Okay. From the art, you know that if you play many times, okay, the art is actually 17 divided by 6 plus 17. You will sell.
Hmm.
Can you see this? So the art is actually 17 divided by 17 plus 6 that you will sell,
Yeah.
right? So most probably you will sell. Okay. So based on this, so you know how to solve the zero-sum game. Okay. Remember the birthday, the Frank that forget his wife birthday.
Yes.
Okay, you remember that?
Poor Frank.
Okay, using the same computation like this. Can you find the using algebra? Anyone want to try? I don't think I put it here, but can you calculate? This is only the answer. I did not show the computation. So can you? Anyone want to compute using algebra? Share your screen. Claim your recitation point. Come on. Who did not get recitation point today?
Stephen, I think.
Hey,
I think Steven.
Stephen.
You're not Stephen.
Oh,
Where are you,
Stephen, your
Stephen?
chance, your chance.
Yeah, sir. I don't with my laptop, sir.
Hey,
I don't have my laptop right here.
so you are using a mobile phone?
Yeah, sir.
Oh,
Until next week, maybe, sir.
okay.
It's on service.
Write whiteboard in using mobile phone, or you can use paper and then show your screen. You can screenshot if you want.
Okay, maybe after this, sir.
Oh, okay. So, anyone else? Abel, Darin, Lillian, Eugene, Michael, Nyoto.
I would like to try, but yeah, I'm not very good with math, so I don't know.
Algebra only.
Okay, wait.
This algebra you learn already in junior high school, isn't it?
Yes.
So, and you can try. You want to share your screen?
Yes, sir. Wait. 1 minute.
Yeah. At this point, we learn about computation, right?
So the wait, where is it? You use whiteboard again, or
It's up to you.
so
Okay, write down the K matrix.
0 with the odds, right?
The K matrix is 0, -10, 1, 1.5.
0. You can see what I'm writing, right?
Yes. But
One.
but my question is, how do you get the R? You know, this is already the answer. So I want you to get, how do you get the 0.5?
Oh, how to get this?
Yes. Okay. So in that case, you put X there, right? That is X. And then that is, okay. That
This
is
is the Y.
correct. Okay. And that one is 1 minus X. The second row. 1 minus X, right? And then that one is 1 minus Y. Okay. Then you compute. Remember how to compute? While ago.
Wait. So
So
X is 0.
yeah. So first you want to calculate the X, okay?
Yes.
If you want to calculate the X, what you will do? You will multiply 0 times X plus, right?
Plus 1
1 times
minus X.
1 minus X equal
1.
minus 10 times X, right? Plus 1.5 times 1 minus X. Okay, and then now you solve for X. 1 minus X. And then you can solve for X, right?
So this
Minus X, correct? Equal minus 10X. And then 1.5 minus 1.5 times X. Okay, then you can just solve X.
so 1.5 move to here. So 1 minus
So put all X compo terms in the left-hand side. So you have minus X, right? And then plus 10X minus, now become plus 1.5X, right?
yes.
X equal, so all the constant on the right hand side, 1.5 minus 1. Okay, so what is that value then?
So this is it.
So minus 1 plus 1.5, so positive 0.5, so now become 10.5. Is that correct?
Yes, sir.
10.5x in here 0.5. Is that correct? So x equal 0.5 divided by 10.5. Okay. So you use calculator for that. Anyway, if I multiply by 2, so you will have 1 over 21. Is that correct?
Yes.
Okay, so x is 1 over 21. Okay, then the same thing, now you calculate the y. So you write down the x on your whiteboard on the left, so that you can remove the computation. So x equal to 1 over 21, is that correct? Okay, now the computation for the x you can remove, and you calculate now for the y. Okay,
We do the same.
yeah, similar, not the same, but similar. Now for the column.
So now y times 0.
Yes, y times 0 plus minus 10, right? Times 1 minus y times that one. Minus 10 times, not top.
Oh,
Minus 10 multiply 1 minus y. Okay. Equal to what? Equal to the second row, which is 1 times y plus 1.5 times 1 minus y. Okay. Then you can solve for y. Can you solve it?
minus 10 plus 10y equals y plus
Plus 1.5
1.5 minus 1.5
y.
y.
Okay.
So
So we
10y plus
y
1.5 y minus y equals
1.5 plus 10. Okay, so what is the value? Again, 10.5 equal to what? 11.5. Okay, so y is 11.5 divided by 10.5.
So it's
23 over 21.
Okay, 23 over 21. Correct. Okay, so now you know x and y. Okay, if you multiply all by 21, you get the out.
multiply all by 21.
Correct, because the denominator is 21, right?
Yep. So I
Y is equal to 23 over 21. Okay, so you can put the out there.
here.
Yes, the x you put 1.
Oh, x.
1.5. So x is 1, right?
Yep.
And then 1 minus x is supposed to be 1 minus, that is the 22, right now? Hey, sorry, 20, is it correct?
1 minus x.
No,
1
because you
minus
multiply
1,
by 21 first, all. So meaning 21 minus 1,
20.
correct. Is that correct?
Yeah,
Okay, now y is 23.
23. And this one is
Now 23 minus, so 20
minus 2.
21 minus 23. So minus 2.
Yeah, minus 2, right?
Is that so? No, cannot be. So y is 23 over 21. Is it correct? The y is 23 over 21. Yeah, positive. Correct. So, what is strange? Why probability can be negative? Oh, no, the y in here is 23 over 21. Are you sure the y is larger than 1?
Wait, why is it?
Maybe
But
maybe something wrong with the computation. Probability
so
cannot be larger than
0
1.
y 10 minus 10 times 1 minus y. Oh, wait, is this supposed to be minus? Oh,
Must be something wrong
No,
with computation.
no. I think it's not
10.
10.5, but 9.5. Yeah, I think.
9.5, is it?
Wait, you got from the second line, yeah, you got minus 10 plus 10y equals to y plus 1.5 minus 1.5y. So if you, oh no, that's right.
The correct one is must be minus 10y, not 10.
yeah, this one is minus 10y. I'm so sorry.
Oh yeah, that is minus 10.
Yeah.
Because probability cannot be negative, you know.
So this one minus 10y. So where is it? Minus 10y.
Wait, why is it minus Nyato?
This one, Eugene. It's
No,
Minus-
minus
yeah.
times minus is plus.
Yeah, minus 10 times minus y.
Oh yeah, it's plus, yeah. Yeah, I did that correctly.
Yeah, I think Nyato did the calculation correctly. Though. Maybe the question itself got some problem.
Anyone have a better solution for this? Did you calculate by hand?
Yeah, the odds is larger than 1, yeah, when you have 11.5 divided by 10.5. It's 1.09, it's 1.1 something. Should be only 0 and 1, right?
This one is 0, this is correct. And then what is the other one? Minus 10 times 1 minus y, correct? And then the second one is y. And then what is this 1.5?
Yes, 1.5.
Where does 1.5 come from?
This?
Okay, the value of the game, yes. 1.5 times 1 minus y, that is correct. So this one is no more. And then this one is minus 10 plus 10y equal to y 1.5 minus 1.5y. This is second row is correct. Now the third row, you put all 10y minus y plus. So in the left hand side, in the right hand side, in the second row, that is already minus 0.5. So become 10 point, eventually you will get 10.5, that's correct. 10.5y, can you put 10.5y? Not 11, this one, 10.5y. Right. And on the right hand side, you have 1.5 plus 10, so 11.5. That's correct. So the y is 11.5. That is correct. So okay. So if you put that 23, the y now become 23 over 21, right? And then 1 minus y become minus.
Minus 2.
Minus 2. Okay. Okay. So minus the odd is meaning that the odd is actually very low.
This one is the odds is 20 to 1.
Correct. For the human player, the odd is 1 over 20, right? So it is correct. So for the nature, that is the one that I still doubt. Anyway, so you can check the computation later, okay? And you can see that actually the odd for the human player is already correct, which is 20 over 1.
Oh yeah, it's already, yeah.
Correct. Huh? Okay. Now, the value of the mixed strategy, okay, when you see that, the average payoff is always the same, okay, when good mixture is found, right? When you found the actual probability or the odd in here, you will find out that the game value now is always the same between the row and the column. Okay. Now, can I share my screen now?
Oh wait, I think
Okay.
I found. Wait. What
Okay.
did I write here? Wait, sir. Oh wait,
Okay.
already minus 10. Okay, or I thought I put 10 on the matrix. I think yeah, it's already correct. I don't know why we got minus for the probability.
Yeah. Anyway, let's check the computation later, huh? Okay. So at this point, I want to share with you another technique to get the odd, but this is a limited edition, limited series. Okay, meaning this is only work for 2 by 2 or 3 by 3. Okay, this only work for 2 by 2 or 3 by 3. So this technique is limited only 2 by 2 matrix or 3 by 3 matrix. It's not work for any others size of the matrix. Okay, so the technique is to find the difference between rows and to find the difference between columns. You see this in this example? Can you see my screen?
Yes, sir.
Okay, so this is based on the rule of thumb. If you find the row, first you find the row difference. So you see -7 minus 1 is equal -8, right? So for the drill, minus with the cell equipment. So 10 minus -5 is 15. So then the first you get the difference between row. Second, you get the positive values and then you reverse it. Now the odd is, in this case, 15 over 8. Okay. Similarly, for the arc for the rows now, you find the difference between columns, you get the positive values, and then you reverse it. So then the arc in here is 6 over 16. So this is easier, right? So say if you want to find the solution of this, again, you can calculate the difference, and then you can calculate the arc. Can you do it? Oh, maybe the problem a while ago, this one. Can you find the arc? So for the columns, you find the difference. So the difference is 10 compared to what? 1 minus 1.5 is 0.5. So the difference is 0.5 and 10. Oh, now you get that value. The same thing in the columns. Right? So you for the arc of columns, you find the difference between rows and then put them into absolute value, positive value, and then you reverse. Okay, so for the column here, you get the difference between rows. So 0 minus 1 is minus 1. 10 minus 1.5, it is 8.5, correct? You take the positive value and then you reverse it. So you get that out, 8.5 and 1. Can you see it on? Anyone still confused, or you know already? Any question?
It's quite clear. So yeah.
Quite clear?
Yeah.
Okay, so Eugene, you think it's quite clear? Can you solve this one?
So I need to make the comparison like before, right?
Yeah, can you solve this one using the arc? Can you calculate the arc of these schemes? Okay, you share your screen, manually compute.
Wait, yeah, I hope so. Oh wait, what was the question again? Sorry, sir.
Can you calculate the arc of this game? 3,
Okay, wait.
2, 4.
Yeah, can you show me the question again?
3, 1, 2, 4.
3, 1, 3, 1, 2, 4. Okay.
Yes. Okay. Share your screen or whiteboard, and then you calculate. So using this technique, okay, you don't need to use algebra.
So you just minus the value. So
Correct.
the
You
column,
just minus the value between rows, between columns.
yes.
So like I do 3 minus 2.
3 minus 2.
3 minus 2 is what? 1.
1. Then 1 minus 4 minus 3.
1.
Right. 1 minus,
then I have
minus 3
1 minus 4
is equal to minus 3.
minus 3.
Okay. And then to take actual value, meaning that the arc
So
1 and 3. and then you reverse.
3, 2, 1.
Correct. 3 to 1.
So I will have the result like this.
Okay.
Wait, huh? Oh,
What your laptop
Yeah.
so smart, Eugene.
yeah, smarter than
Changes,
me.
changes
Yeah.
everything into
Yeah.
table.
So
Okay.
that is 3. Okay, so you look at the screen I have now. Can you?
Okay, wait.
You?
Wait, sir. For the column one,
For the column, the same thing.
it's 2, 2, 2, 2, and 2, right?
So the columns, so the art is
Yeah.
what?
2 and 2.
1,
Yeah.
1 to 1, so
1
sir.
to 1. That's correct. So now the art is you can see. Easy, right?
Yes, sir. less complicated.
Yeah.
Very
Very
less
fast to compute, okay?
Yes, sir.
But unfortunately, this is only 2 by 2 or 3 by 3. Later, I will discuss about 3 by 3. In 3 by 3, you calculate the determinant. Here. Again, using rule of thumb, okay? This technique is very fast to compute, okay? Again, you subtract each row from the preceding one, okay? And then you delete column that you want to find the odd. After that, you compute the cross product of the matrix. The odd is to compute it using this one. The absolute value of AD minus BC. You remember this? If your value of the matrix is A, B, C, D, okay, you compute the odd by AD minus BC. Can you see the diagonal minus the off diagonal? Okay, I give you an example. So say you have this 3 by 3 matrix, okay, A, B, C, and then D, E, F for the column, A, B, C for the row, right? So what happened is, for the row, okay, for strategy D, now you want to find the odd for strategy D. So first you take the difference between the row. So you get A minus B and then B minus C. Okay? See, right? Until this step. And then because you want to find the odd for strategy D, what happened is you remove column D. Remember, what you want is to find the odd for strategy D. Okay? So, wait, I will put the color here so that you know. I want to find the odd for strategy D. That means after I find the difference, I remove D. Okay? So there, I remove D. Okay? Then, now you have, this is A, okay? This is B, right? This is C, and this is D. Okay? So, what you will do, AD minus BC. And then you take the absolute value, you get 38. That is the odd for D. Clear or not? Then you do the same thing for the next one. Is it clear? For the row, it's the same thing, okay? You subtract each column from the preceding one, and then you delete the row that you want to find the odd. And then, again, you do AD minus BC. Okay, so in here, for example, you want to find the odd for strategy A. Okay, the odd for strategy A. So then you take the difference. So D minus E, E minus F, right? But you want to find the odd for strategy A. That means A you delete. So in that case, you have this A, small a, this is B, this is C, this is D. Okay? Then you get AD minus BC. This is the odd of strategy A. Clear or not?
AD minus BC. Okay.
Okay. Diagonal minus off diagonal.
It's like determinant.
Exactly. So now you see. Okay. But this is only for 3 by 3, okay?
Okay, sir.
It's only for 2 by 2. This is a trick. You got it or not?
Oh, so okay.
This is a trick to compute fast. Okay. If you want to, otherwise you will using algebra, right?
Yes, sir.
You use
Right.
X, you use Y, okay? Let's take a long time, right?
Yes, sir.
So this is a trick to calculate very fast. Using your eyes, you can do it. Okay. So if you are in the exam, okay, be careful. This rule of thumb technique is a trick, right? Is to find the R is only for 2 by 2 and only for 3 by 3, okay? This is very nice method, very fast, but it may give fast result if you apply to a game that having a saddle point. Okay, so now, in that case, what is the step, okay? If you want to find the equilibrium, okay, of a zero-sum game, okay, you need to find first the saddle point. Check if there is a saddle point. What is the, how to check the saddle point? You remember? Minimax must be equal to,
Maximin.
right? So if you cannot find saddle point, the second technique you use domination strategy. Okay? If you cannot use domination strategy, then you use algebra or you use the rule of thumb. Okay? Don't use the rule of thumb immediately, because if you use the rule of thumb immediately and actually you have saddle point, you will get false result. Remember, huh?
So we check first whether it has saddle point and then
Domination. Okay?
oh, the
This
domination.
method may give false result. I give you warning already.
Okay. Yes, sir.
Okay? Don't immediately use this technique. So you use the how to find saddle point, which is easy, right? Minimum, maximum, okay? And then maximum, minimum. Check the value, right? Finding saddle point is not difficult, right? So if you cannot find saddle point, try to use domination. If you cannot find domination, then you use algebra or this rule of thumb. But be careful, this rule of thumb is very fast trick to compute the R, okay? But only for 2 by 2 or 3 by 3.
Wait, sir. So can we use it for the flower?
Yeah, of course. Flower you already did.
But we didn't find
This
the
one, this is the flower, right? Here. Okay, you
oh,
see?
yeah.
What is this?
This
This is
one
2 by
minus
2. So
minus 1 and
0
then
minus 1. Okay, and then the other one is 8.5.
oh yeah, okay.
Okay, so fast.
Yes, sir. So yeah, no need to use
Correct? Very fast,
yes,
right?
sir.
No, you don't need to compute that and then you still make mistake by in computation.
Yes, I mean using algebra we found 23 over 11
Right,
over
so
21.
right, so it's very confusing. So using this technique is so fast, isn't it?
But yeah, must be careful.
Yeah, but you must be very careful. Okay, so if there is a saddle point, don't use. Okay. So do you want to continue? Okay. So okay. At home, after the class, you try to find the solution of rock, scissors, paper game. Okay. Try to compute. Is there any?
This one using the determinant thing.
No, this one you first you use saddle point. After that you use domination. After that you use algebra. Okay.
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 Yes.
Hmm.
Yes, sir.
Okay.
Yes.
Okay. So okay. And this is the answer. There is no solution.
Can we just discuss it? I'm so confused.
You're still confused. Okay. So you compute first. Because if you don't compute, if I give you the answer only, you will say, oh, you're just memorizing, right? So I don't want you to memorize. Try by yourself. Do compute by yourself. Can you find the saddle point? Practice lang. Okay. The same thing. Can you calculate this arc of the row and the column? And then you compute the value of the k. So this is the example of exam. Okay. I give you the example of exam here. I give you this, the arc, and then the multiple choice I will give you. For example, the arc for Miss A is something, the arc for Mr. Column is something, then you will select all the possible correct answer. If you don't calculate, of course, you cannot get it. Is that clear?
So
So you practice first, okay? All of these are practice. So meaning that, look, if you don't do the practice, if you don't do the practice, you will not be able to solve the exam. In the exam, I will promise you something. In the exam, there is nothing go out of the slide. Even
okay.
the numbers will be exactly the same as the slide. But if you don't practice, you will not know the answer. If you practice and you make note in your own slide, you know the answer, and you practically just searching your own answer. Because
So for this one, sir, for this like for the one that you show like this, can I use the
yes,
the
you can use the trick, the rule of thumb.
the rule of thumb?
Correct. Remember, in the actual exam, midterm exam, for example, the time is limited. You understand? It's multiple choice. You have so many questions, not just 3. Okay, and your time to compute is limited. If you don't compute it before the exam, I think it is not enough. Your time is not enough. That's how you prepare. Is that okay? So
Yes, sir.
all these
Okay.
practices, the rock, scissors,
Yes.
paper, these 3 example of the, okay. The answer is here, but can you calculate by yourself first? So that, and if you have any question, please discuss it next meeting. Okay. Is that okay?
Yeah. Okay, sir.
Look at this. Actually, if you compute all, you will see there are exactly the same. You see. So my question is, does it happen by accident that the art is actually all the same? Why the art are the same? Okay, think about it and we discuss next meeting. I don't think we'll enough time to go. So next, if you read this slide and then you try on your own, okay, try to do it using Excel. Can you? Using solver. So that we can solve it easily next meeting, okay? So what did you learn today?
You can make complicated stuff simpler using rule of thumb. That's what I learned.
Okay. Darin, what did you learn today?
How to solve some game problem.
Okay. So, Eugene, can you calculate can you make a game matrix from your real life problem? Do you think?
I think I can, but most
Okay.
of the time I would think it's a bother, so I would just go with my feelings.
Oh no. How about you, Lillian?
I'm sorry.
Can you make a game matrix of
Hello.
your real life problem?
I guess if I know the payoff, because I think there's no
So,
exact payoff.
okay, if you don't know the payoff, the exact payoff, you can guess it as long as the order is the same. Remember, the payoff is not real value, but actually order. It's an ordinal value. It's utility. Okay?
Mm.
Guess the order, meaning which one is bigger than this one.
Okay, okay.
Okay? So if you know which one is bigger than the other one, then of course you can make the payoff. Okay? Stephen, what do you think? What did you learn today?
I got something new about the rule of thumb, sir.
Okay. So you're amazed with the rule of thumb. Abel?
Yeah, I learned how to make strategies against my opponent. Pick the optimal strategy.
Okay. So you can predict, right? What is the opponent will move. Okay.
Yeah.
You think?
Yeah, we know their best move and what our response is.
Yes. What is the best move and what is the response is. Very good. And Michael?
Yeah. I'll learn how to what's for rock paper scissors, I think.
Okay. So
Rock, paper,
quantify the
yeah.
rock, scissors, paper.
Rock paper scissors, yeah. That's the one that I must remember, right?
Yes. So the one that you practice, actually the one that you remember.
Okay. Okay. Okay.
Okay. That's good. So if you practice more, you will get better result for your own. Okay.
Good.
The more you practice and the more you use this knowledge for your real life problem, for your decision-making problem, okay, then you will start to value this knowledge that you just learned in this class. Okay. So example, I give you example. I use this also for decision-making, whether I need to go to the Philippines or not during this time of COVID, right? So, and I make decision matrix, okay? And I calculate the cost and the time, and I need to do the quarantine and all these things, effort, and so on. So, based on the decision, I make allocation of the resources. Okay. So I hope the same thing with you. So just anything that you will put some effort, some decision, some resources on it, then you start to use decision analysis in your daily life. I hope that is the message from this class. And I hope the class is not just, learning the theory, but you can also use it in your real life. Okay? So, see you next week then.
Okay. Thank you, sir.
Thank you very
Thank you,
much.
sir.
Yes.
Thank you, sir. See you
Thank
next
you.
week.
Thank you,
Thank
sir.
you.
You.
Thank you, sir. See you.